The second concept in section 4.2 is exponential functions and graphing them. Now when we do exponential functions, our a cannot be 1 because then your whole thing would be 1. So a is not equal to 1. Okay, so really these kind of do the same exact stuff as every other functions. They move left or right, they stretch, they shrink, they move up and down, right? Same kind of concepts. Whatever's with x always moves left and right, and it's always in the opposite direction, that whatever that number is. So if it's x plus 2, that means it's moving left 2, just like quadratics, just like the different type of polynomials that we did. It moves the opposite direction. And then k, what's being added to after you do the exponent, moves up or down. And it moves whatever that, it's the same number. So if it's positive 3, then it moves up 3. If it's negative 2, it moves down. And the asymptote that's talking about here is y. Well, y equals 0 it should be, but it's always y equals k. Right, because we can never have, so like 2 cubed is 8, 2 squared is 4, 2 to the first is 2. So we continue to go down, right? As I continue to go down in exponents, I'm decreasing by my base, right? I'm dividing my answer by my base of 2. So 2 to the 0 would be my previous answer divided by the base 2, which is 1. And then 2 to the negative 1 would be my previous answer divided by my base 2. So no matter what, anything to the 0 is always going to be 1, because I'd get 3 over 3, 4 over 4. So I'm never going to get 0, right? I get 1/2. 2 to the negative 2, that'd be 1/4, 1/8, and so on. So it's never going to cross 0. So the asymptote's always at y equals 0. But if we add something at the end after our exponent, it moves it up or down. So that adjusts the asymptote. So it's y equals whatever our k is, whatever we're adding to after we do the exponent. So on a traditional one, so when it's just, when nothing's being added to, so when it's just y equals a raised to the x, or even y equals a raised to the x minus h, then our domain will always be from negative infinity to positive infinity, and our range will be, well, I can even say plus k is fine too, even the plus k one will be, because here on the first one our y equals a, our k would be 0, right? So our range is always going to be from k, and it's never going to hit k, right? That's always going to be, it's a horizontal. Did I say vertical at the beginning? This is a horizontal, right? It's y equals, so that's horizontal. So it's always going to be from k, but not going to hit k to positive infinity. If it's a positive, right? Because we still have that thing where if we have a negative out front, that flips it over the x-axis. So that's true too. So this is when it's just a positive here in front of the a. So if it's a negative in front of the a, if it's a negative, then it would be from k down to negative infinity would be our range. Or it would be from negative infinity up into k if a is negative. Okay, that would be our range. Our domain would still be the same, negative infinity to infinity. And that a being negative would be in front, right? So like that. Okay, so let's go ahead and do some examples here of graphing and labeling the domain and the range. And really, all you have to do is just make a chart, an XY table. I guess I can tell you what it looks like, right? These are all going to look like, which I haven't told you, they all have that horizontal asymptote, right? So they're all kind of going to look like that. They're going to continue to decrease but never cross this line, and then continue to go up, right? So that's what they're always going to look like. That's what exponentials basically look like. A to the the basic one would be 2 to the x, right? 3 to the x would increase a little more faster, x to the fourth would increase a little more faster, and so on and so forth. But they all, when I plug in 0 in for x, if it's y equals a to the x, what's anything raised to 0 would be 1, right? So they all kind of intersect at that point 0, 1 actually. They would all intersect there and then go up from there. But this one, this first example here, we're subtracting 4, so I would subtract 4 from that 1, and I would get negative 3. And then I can put in 1, so that's 2 to the 1 minus 4, which is negative 2. I can put in 2 squared minus 4, that would be 0. I can put in 3, that's be 2 cubed, which is 8 minus 4, which is 4. So that's probably enough points to graph. So we got 0, negative 3, 1, 2, 3. We got 1, negative 2. So 1, negative 2. We got 2, 0. And we got 3, 4. Okay, so if you think this continues to go down, well, we already talked about this is our vertical or horizontal asymptote, right? At y equals negative 4. So at negative 4, it's not going to cross there. And you can see that if you put in negatives. How about negative 1? Well, that's going to make it 2 to the negative 1 minus 4. So that would be 2 to the negative 1. Isn't that 1 over 2? Right? That negative exponent creates a fraction. And we can put that base now on bottom with a positive exponent of 1. And then minus 4, that's 3.5, right? Negative 3.5, and so on. So it's going to stay below 4. So it's going to look like this and continue to go up. So that's how that graph looks like. See how it moved down 4, our horizontal asymptote? Okay, now how about this one? Let's just put these all on the same graph so you can see the difference. So again, you can just make a chart, or you can use those techniques from chapter 2 to go ahead and graph this, right? Here I'm not adding anything, so my k is 0. So it's going to go at 0 here, would be the horizontal asymptote. This is x minus 3, so that means it's actually going to move right 3, 1, 2, 3. So this is kind of like my new, this line right here, that would kind of be like my new y axis there. And then it'd be like your points 0, 1. Normally with your x and y, if it was just y equals ax, this would be 0, 1, right? Anything raised to 0 is 1. 1a. 2 would be a squared, right? So those are the basic ones. So if you use those techniques from chapter 2, you get your horizontal asymptote, and then you'd move based on what's being added to or subtracted from x, but always the opposite. And then you would just graph these points, 0, 1, 0a, and 2a squared. But since that negative here, that negative what we just talked about on the previous slide was it's going to flip it, right? And we can see that as we start plugging in numbers. So let's go ahead and plug in 0. Which changes a little bit, right? Because it's minus 3, so it's negative 2 raised to the 0 minus 3. Well, 0 minus 3, we're going to need some more room. Okay, so 0 minus 3 is negative 3, right? So we got negative 2 raised to the negative 3. Now this is 2 raised to the negative 3 and then multiplied by the negative. So it's like negative 1 times 2 to the negative 3. Right, that negative I have to wait to do the exponent first. The exponent's 2 to the negative 3. Well, that's 1 over 2 to the 3, and then times by that negative. So then we get negative 1/8. So we can go ahead and graph that. 0, negative 1/8. Oops. So I can. Okay, so here is 0, negative 1/8, and we can see. As we put in numbers like 1, so let's go ahead and put in a 1 into this. So negative 2 raised to the 1 minus 3. That is negative 2 to the negative 2, which is negative 1 over 2 squared, which is negative 1/4. So negative 1/4, which is a little bit bigger, right? And we can see that this graph is going to continue to go up. Let's put in 3 and see what happens. So negative 2, 3 minus 3, which is negative 2 raised to 0. Anything raised to 0 is 1, but we have that negative in front, so it's negative 1. So at negative 3, we're at negative 1, which is right here. So we can see that the graph is going to approach this way, and then it's going to increase this way. So see how that negative out in front flipped it over the x-axis, just like it did on your quadratics and stuff. So there's that graph. Okay, let's go ahead and do this last one. And we'll put those on a graph as well. So let's go ahead and put in negative 3 as our first x. So that would be 2 to the negative 3 plus 3, and then after I do my exponent, then I'm going to add 1. So that means my y value, that would be 2 to the 0, and then plus 1. Well, 2 to the 0 is 1, so 1 plus 1 is 2. So we have negative 3, 2. So negative 3, 1, 2, 3, and a positive 2. And then we have, say, let's go negative 2. That'd be 2 to the negative 2 plus 3, and then plus 1 after I do my exponents. So that'd be 2 to the first plus 1, which is 3, so negative 2, 3. So that means it's kind of going up from here, right? It's increasing. What about to the left? What about negative 4? Well, that would be 2 to the negative 4 plus 3, and then plus 1 after I do my exponents. So that would be 2 to the negative 1, which is 1/2 plus 1, so that's 1.5, 1.5. So that means it's going down, but what is it not going to cross? Well, it's not going to cross that plus 1, as I can see by putting in, let's put in a really big number here. Let's put in a big number like negative 10. So negative 10 in for my x. So that's 2 to the negative 10 plus 3, and then add 1 after I do my exponents. So that's 2 to the negative 7, and then plus 1. Well, that is 2, well, that is 1 over 2 to the positive 7 plus 1. 2 to the positive 7, can't think off the top of my head real quick. 32, 64, 128. 128, yeah. So that is 1 over 128 plus 1, and 1 over, so that's 1 and 128 is really, it's just bigger than 1. It's just barely bigger than 1, so it's never going to cross that line, y equals 1. So there's a boundary here. So it's never going to cross that. So this looks ugly and stuff. Let's clean it up a little bit so we can see that here's our kind of graphs a little bit. So a negative at the end, after we do the exponent, drops it down for the blue one. A negative out in front, and the negative on the x actually moves it right and then flips it. The negative out front flips it over the x-axis. The negative on the x actually moves it to the right because it's always opposite. And then we can see on the last one, the black one, it actually moved our original. This is our original. Something like this. Doesn't cross 0, cross that 0, 1, and continues to go up. So the black one moved left 3, and then up 1, because it doesn't cross 1, and then there's our graph. So that's how you graph exponentials. I'll go ahead and do the homework on these 29, 31, and 37.